The transport of radioactive material forms an important part of international trade. Every year, over 1 million consignments are handled and shipped by transport operators throughout the world. The use of radioactive material is widespread. In industry, their applications can range from examining large steel fabrications to ensure freedom from flaws, to checking the integrity of welded joints on high-pressure pipework. In the field of agricultural research, radioactive tracers are used to study plant and animal life and to develop new fertilizers and pesticides. In medicine, radioactive materials are used for both diagnosis and treatment of disease. For diagnostic purposes, a small amount of radioactive material can be given to a patient, and the display of a scanning device indicates the condition of organs or glands within the body. The radiation emitted by a cobalt source can be used for the treatment of patients with malignant disease. In many countries, electricity is produced from nuclear power, and the transport of materials from this industry forms the largest tonnage of consignments of radioactive material. Shipments take place by all normal means of transport. The only practical limitation on the form of transport is generally the size and weight of the package. This freight train carries a consignment of irradiated fuel from a nuclear power station. The containers, often called flasks or casks, weigh over 50 tons but carry less than 2 tons of radioactive material. Road transport can be used for medium-sized loads. Consignments for medical use are generally smaller in size and lighter. Because of the short life of these materials, often measured in hours or days, speed is essential in their delivery. So that's why air transport is used for long distances. The regulations for the safe transport of radioactive material are agreed upon by the member countries of the International Atomic Energy Agency and are supported by other international organizations with an interest in the safe transport of dangerous goods. They form a comprehensive basis for providing adequate protection of workers and members of the public, property, and the environment. To understand the procedures laid down in the regulations, let us first see what is meant by radioactivity. There is nothing new about radioactivity, for it is present in our own natural environment. Rocks, soil, water, and vegetation contain natural radioactive substances which have been around us since Earth began. Scientific developments over the years have resulted in the creation of radioactive substances beneficial to people. Transporting these materials from producer to user is an essential service. A radioactive substance continually emits invisible radiation, which, unlike light or heat radiation, cannot be seen nor felt by the human body. This radiation can, however, be detected and its intensity measured by a radiation monitor such as this. In this demonstration, we use a sealed radioactive source, which is safe to handle. When the source is taken out of the container, the monitor immediately detects the radiation and produces an audible signal. The intensity of the radiation is also indicated by the monitor. If the distance between the source and the detector is increased, the radiation intensity decreases, just as the heat decreases from a fire as you move away from it. Radiation has varying powers of penetration. One type, alpha, can be stopped by a thin piece of paper. Another type, beta, can be stopped by sheets of light metal. The most powerful and penetrating is gamma radiation. This can be absorbed and reduced to a safe level by materials such as lead or steel. Open radiation sources present two types of hazard. Firstly, contamination of the body by direct contact with them, and particularly through inhalation. Secondly, the emission of radiation which can directly penetrate the body and cause damage to internal organs. However powerful the source, distance and limitation of exposure time can always give you protection against radiation. To contain these hazards during transport, radioactive material is enclosed in a sealed container to prevent any leakage of the contents. The container is then surrounded by a shield of dense materials such as lead or steel, which reduces radiation to safe levels. With proper packaging, therefore, these containers are perfectly safe to handle. Regulations developed by the International Atomic Energy Agency provide standards of safety for the packaging and safe transport of all radioactive material. Many facilities around the world prepare radioactive material for use in industry, research, and medicine. Let us now see how these materials are prepared and packaged to conform with IAEA regulations. First, we go to a production line. In this enclosure, bottles are being filled with a radioactive isotope required for medical use. After filling, the cap of each bottle is placed in position, creating the first level of containment. Strict procedures are followed throughout the process of production and packaging. Each bottle is placed in a lead pot, which acts as a shield against radiation. Before the bottle is enclosed in the pot, an absorbent pad is placed inside to absorb twice the liquid volume if the bottle were to be broken. The radioactivity of the contents of each bottle is then checked against the specification to match the label on the lead pot and is recorded. The pots, assembled in a tray, are transferred to the packaging section. This transfer is carried out through a series of transfer boxes made out of lead and steel to provide an additional shield against radiation. In the adjacent room, there is the packaging line. This is where the transfer boxes are opened on the other side. The pots are now placed in a metal can. Packaging inside the can fits snugly around the pot, to protect the contents from shocks. Each can is labeled on the outside to identify its contents. The can provides an outer form of containment after the lid has been sealed into place. Each consignment is then prepared for dispatch. IAEA regulations define the type of package to be used for every consignment. Regulations also stipulate that packages of radioactive material shall carry a label which clearly identifies the contents. When radiation from the package is so low that there are no restrictions on handling and storage, a white Category 1 label is used. The label also shows the principal radioactive content and activity. Higher levels of radiation are indicated by yellow Category 2 and yellow Category 3 labels. In addition to showing the radioactive contents and activity, yellow labels also identify the transport index of the package. The transport index is based on the maximum radiation level at 1 meter from the surface of the package, or on the fissile properties of the contents. The index provides a basis on which consignments must be segregated from persons and photographic film, which could be fogged if exposed to radiation. The size and shape of the package is not an indication of the radiation emitted by the contents. The color of the label and the details on it are the only true guide. Some consignments, pharmaceutical products for example, have such a low activity that they are classified under the regulations as accepted packages. They are so identified on the transport document, and no externally visible package labels are required. The range of packages used to transport radioactive material is considerable. Type A packages are used to transport small quantities of material which will present little hazard even if the package was damaged. Standard industrial containers can be used to transport materials of low average concentration which are relatively safe in their own right.